In this program, we'll look at structures in C++. A structure is a way to group several variables together under a single name, creating a logical unit. At the top of the code, we define a structure called car. It has three members: a string for the car's brand, an integer for the year, and a double for the maximum speed. Think of it as designing a template for what information a car should contain. Inside the main function, we create two variables of type car, one called car1 and one called car2. For the first car, we set the brand to Toyota, the year to 2015, and the maximum speed to 180.5 kilometers per hour. For the second car, we assign the brand Ford, the year 2020, and a maximum speed of 200.0 kilometers per hour. Finally, we use countout to print both cars' details in a nicely formatted way. The output clearly shows each car's brand, year, and maximum speed. The advantage of using a structure is that all the information about a car is grouped into a single variable. Instead of managing three separate values for each car, we just manage one variable, like car1 or car2. This makes the code easier to organize and extend, especially in bigger programs where you might store dozens or even hundreds of cars. Now let's move on to another fundamental concept: functions. We've already been using built-in functions such as main, size of, and sqrt. But how can we create our own function? That's exactly what this example demonstrates. At the top of the code, we declare a function prototype: double, rectangle area, double length, double width. The prototype is like a promise to the compiler that this function exists. It lists the return type, the function's name, and its parameters. Without a prototype, the compiler will give you an error if you call the function before it has been defined. Then we define the function. It takes two parameters, the rectangle's length and width, multiplies them together, and returns the result as the area. The variables length and width here are local variables, meaning they only exist inside the function. Once the function finishes, those variables disappear from memory. Inside the main function, we first call rectangle area 5, 3 to calculate the area of a rectangle with length 5 and width 3. The program prints out the result. After that, the program prompts the user to enter their own length and width. Those values are stored in the variables L and W. The function is then called again, and the area of the user's rectangle is displayed. Notice how the function can be reused as many times as we want, with different values. That's the real power of functions. They allow us to write code once and then call it whenever we need it. In fact, you can even save your function in a separate file and include it in other programs, just like you include standard libraries.